Hello everyone, my name is Emiliano Larach, and today I'm going to be going over lab number 4 for Physics 2212, which deals with circuits and capacitors. I'm with Dr. Jang section, and here we go. First, a little bit of a background on what we did for this lab. We used a multimeter to measure various aspects of a circuit, such as the voltage drop or difference across the circuit, the current, and the resistance of the circuit. Some of the materials we used were resistors, light bulbs, capacitors, and batteries. First, in a little description about our circuit, we had two 1.5 volt batteries connected in series, which total up to a 3 volts across the circuit. But in real life, our circuit, you will see that only had 2.7 volts. This is because the batteries were a little discharged. With these 3 volts, my predicted current I1 and I2 are the same because it's a series circuit, and it was 20.4 milliamps. My actual reading of the current on my circuit was 15.5 amps, milliamps. So we can see there is some difference in these two numbers, and this is just because the difference in voltage, this number here is calculated with 3 volts and not with 2.7 volts. And this is a photo of my circuit. You can see in here that is 15.5 milliamps. Then when I reversed the ammeter, the current stayed almost the same. It just went negative because the conventional current was going into the negative terminal of this multimeter. Then for checking the actual voltage, as I said, was like 2.6 volts, was exactly 2.6 volts. And the current changed when the voltmeter was connected. So when I connected an extra voltmeter in here, my current changed considerably. Then measuring the difference, the voltage drops across the circuit. So in each of these segments that you can see in here, they do add up to 2.7 volts, which was my total volt that the battery was giving. So this is an important concept, that the voltage drop across every single element of our circuit needs to add up to the total voltage that the battery is providing. Then this is the graph that I did for the approximate graph of potential difference. You can see it comes from 0, goes to 3 volts or 2.7, and then it goes back to 0. Okay, when I attached the multimeter, the circuit is altered, but why doesn't the ammeter really change? This is because current depends on voltage and resistance, and the ammeter has a very small resistance, so it doesn't affect it. Then when I connect the voltmeter across the 100 resistor again, the ammeter didn't change at all. And when I replaced the voltmeter with an ammeter in parallel with the 100 ohm resistor, the current through the other ammeter doubled. And this is because a current always finds the least resistant path. And when I connected two resistors in parallel, so the resistor of 100 ohms and the resistor inside the ammeter, current went through the small resistance resistor in the ammeter and bypassed the 100 resistor. So it was like a 50-50 split of the current going through, because when we have two resistors, that remember that the formula is 1 over R. That's for parallel resistors. So when we connect two resistors in parallel, the total resistance drops. Then the resistance to one of the series circuits, this was the resistance that I calculated. And for the RC circuit that I built, the light bulb got dimmer as the capacitor charges and turns off when equilibrium is reached between the capacitor and the battery. Then when the battery again is disconnected, the capacitor discharges and the bulb is very bright at first but gets dim as the capacitor discharges. And this is the difference in voltage for a capacitor. We can see in here, will be sliding here. And for the 20 ohm, for the capacitor in both cases took 5 minutes and 36 seconds to recharge. And for the 10 ohm light bulb, it took 1.06 minutes to discharge the capacitor and 40 seconds for the 20 ohm light bulb. This is my capacitance graph in the in the non-real life case, and it took 6 seconds to recharge versus 5:36, which is one of the what if questions. And if I'm completed this lab with real circuit components, access the virtual circuit and see if you can determine how it behaved differently from the real ammeter used. It behaved differently because my ammeter has some resistance to it and the one virtually didn't, so it's an ideal ammeter, and that caused for me to have like a little bit of a skewed results. And I completed this lab with real circuit components, and that's the second what if question. and it's what's the different time it takes for the capacitor to recharge. I know the capacitor took 60 seconds to recharge, while mine took 5 minutes and 36 seconds, and this is because of the power of the battery had. My battery was a little bit discharged, and also the capacitor has some extra resistance to it. That will be all for my lab. I hope you enjoyed it as I did. See you in the next one. Bye.